Hey Dr. Martin, so today we'll be doing a circuits equation that I had trouble with and that you helped me with, so we'll be doing it here today. So the first question is, what is the equivalent resistance of the following circuit? So we're going to come over here. If we look the farthest away from our battery, we see that we have a 10 ohm resistor and a 5 ohm resistor. Now, these are in series, so that if we, the equation for the resistance, we'll just be adding them together. So, Kitty is writing that right now. All right, now that we have that figured out, we can see that our next two resistors are both in parallel. So this one, we will have 1 over the resistance equivalence, and Kitty's solving that right now. All right, so you see this circuit, now we're going to go up here, and we see that adding these two are in series, so that we're going to add them again. So Kitty will be solving it. Right, and again we see that these are in parallel, so we're going to do 1 over the equivalence resistance. So we see that here. And lastly, we see that these two are in series, so the last thing we do is just add them together, which Kitty will do right now. Alright, so our answer for the first question for what is the equivalent resistance of the following circuit is 10 ohms. Woo. Now, if we go back to the second part of our question, find the current and the potential difference across each element in the following circuit. We're good. So first we have to kind of do some conceptual thinking. So we can see the circuit flows from the positive side to the negative side of the battery. So the current will start going up through here. We can see that it starts at R1, so and then it'll break off into R6 and R2. So we can see that I equals I2 plus I6. And then for the second part, if we continue along the R2, we can see that it goes to R3 and R5. So we're gonna put that in the equation. So I2 equals I3 plus I5. And then for, if we look back at our circuits that we drew before, in this one we can see that our two resistors are the same. So we know that I2 and I6 are equal. And if we go over here to our second one, we can see that the 15 ohms and the 15 ohms are the same again. So we know that I3 and I5 are equal to each other. So then when we look back at our total our total circuit, we know that V equals IR. So we know that the voltage is 10 and that our whole circuit resistance from our last problem is also 10, and so that would equal to 1 amp of current going through. So because we're starting out in series, we can see that this one will have a current of 1 amp going through it. And then as we get to our I2 and I6, it breaks off, and since we already know that they're equal to each other and then that they both add up to 1, they'll both be 0.5 amps. And for our second node, we know that I3 and I5 are also the same and that they both equal up to 0.5 as found earlier. So we know that both of them are 0.25. And then lastly, for our fourth resistor, it's in series with the third, so it would have the same current, so that would also be 0.25. These are all of our values here. So now when we are looking at finding the potential difference for each resistor, we're just going to plug in our already known values to find voltage. So this is Katie doing it here. So there's our answers for the second equation or second question. So just to make sure we know, these are the currents going through each resistor as labeled over here. And this is our potential difference or our voltage going through each resistor. Thank you.